December 20th, 1944, Krinkelt-Rocherath, Belgium. Obersturmbannführer Fritz Kramer stood in the turret of his Panther Ausf G, watching the morning mist lift from the frozen Belgian countryside. For 3 days, his Kampfgruppe from the 12th SS Panzer Division Hitlerjugend had been hammering against American positions in these twin villages, and for 3 days they'd been stopped cold. Not by American tank destroyers, not by their feared 76mm guns, but by something that made no tactical sense whatsoever. Artillery. Field artillery. The kind of low-velocity howitzers that weren't supposed to threaten tanks at all. Kramer had commanded Panthers since Kursk. He knew armour. The Panther's glacis plate was 80mm of steel, sloped at 55 degrees from vertical. That translated to roughly 140mm of effective armour. No American 75mm gun could penetrate it from the front. The 76mm struggled at anything beyond point-blank range. Even the British 17-pounder needed a tungsten shot and a lucky hit. This was why the Panther existed. Superior frontal armour, superior gun, superior optics. On paper, it was invincible from the front. But in 3 days of fighting, Kramer had watched 5 Panthers brew up after taking hits from American artillery positions. Not random lucky strikes to the side or rear, direct frontal penetrations, from guns that fired in high arcs, not flat trajectories. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. It violated everything Kramer had been taught about armoured warfare. Artillery was for suppression, for destroying soft targets, for killing infantry in the open. It wasn't supposed to punch through the frontal armour of Germany's most advanced medium tank. Yet here he was, 5 Panthers down, and the Americans were still holding Krinkelt-Rocherath like it was Verdun. Something had changed. Something fundamental, and Kramer had a sick feeling that whatever it was, it represented a problem Germany couldn't solve. The attack had begun on December 17th. Operation Herbstnebel, Hitler's desperate gamble to split the Allied armies, capture Antwerp, and force a negotiated peace in the west. The northern shoulder of the offensive depended on seizing Elsenborn Ridge, which meant first taking the twin villages that sat at its base. Intelligence said they were defended by elements of the 99th Infantry Division. Green troops, battle babies. Most had never fired a shot in anger. On paper, it should have been a walkover. But nothing about this battle had gone according to plan. Kramer's Kampfgruppe was elite, veterans of the Eastern Front, men who'd survived Normandy. They knew how to use terrain, how to coordinate infantry and armour, and how to exploit weaknesses in enemy positions. They'd done this dozens of times. But Krinkelt-Rocherath wasn't like other battles. The Americans weren't running, they weren't panicking, and their artillery was doing things artillery wasn't supposed to do. The first Panther had been knocked out on the 18th. Kramer remembered it clearly. They'd been advancing down the main road into Rocherath, Panthers in the lead with Panzer Grenadiers following. Classic doctrine. Use the armour to punch through, let the infantry clear the buildings. The lead Panther, commanded by Unterscharführer Hans Weber, had been moving cautiously, turret traversing, searching for targets. Then there was a flash from an American position, not the crack of a tank gun. Something different. Duller. Like a howitzer. The shell hit Weber's Panther square in the glacis plate. Not a glancing blow. Not a ricochet. A direct hit on the strongest part of the tank's armour. There was a sharp crack, then smoke pouring from the driver's vision port. Weber's voice came over, the radio, tight with shock. Penetration. Front plate, we're bailing out. The crew evacuated quickly, but the Panther was dead. A mobility kill at minimum, possibly an ammunition fire brewing inside. Kramer had examined the hit later, after they'd pulled back. The entry hole was clean, roughly 105mm in diameter, but the pattern was wrong. Kinetic penetrators, solid shot, left distinctive marks. This looked different. The edges of the hole were melted, not shattered. like something had burned through rather than smashing through. And 105mm? That meant American howitzers, the M2 or M3, field artillery pieces, not anti-tank guns. He'd radioed it up the chain. One Panther knocked out by artillery fire. Request clarification on American ammunition types. The response had been dismissive. Artillery cannot penetrate Panther frontal armor. Likely a side hit or structural failure. But Kramer had seen the hole. He knew what a frontal hit looked like, and more Panthers were going to die if they didn't figure out what was happening. The attacks continued on the 19th. This time, Kramer kept his Panthers back, using them to provide covering fire while infantry probed the American positions. But the Americans had turned Krinkelt-Rocherath into a fortress. Every building was a strong point. Tank destroyers were hidden among the ruins, and those damned howitzers kept firing, not in the traditional artillery role, lobbing shells in high arcs from kilometers away. These were firing direct fire, line of sight, like anti-tank guns. 2 more Panthers went down that day, both frontal hits, both from positions where Kramer's men identified 105mm howitzers. One of them, commanded by Rottenführer Klaus Dietrich, managed to radio before evacuating. Hit center mass, glacis plate, penetration complete, ammunition rack hit. The Panther exploded, seconds later, the turret blown 20 meters away. A catastrophic kill. From a howitzer. By the 20th, Kramer had lost 5 Panthers to these mysterious artillery strikes. His battalion commander, Obersturmbannführer Hugo Krass, was demanding results. Why can't you break through? You have Panthers, they have Shermans and infantry. This should be simple. But it wasn't simple. The Americans had turned conventional armored warfare on its head. That morning, Kramer got his answer. During a lull in the fighting, his reconnaissance team recovered shell fragments from one of the knocked-out Panthers. They brought them to him wrapped in canvas. The metal was strange, not solid, like conventional armor-piercing shots. It was hollow, thin-walled, and inside the casing were traces of what looked like explosive residue. The nose of the shell had a distinctive cone-shaped cavity, carefully machined to precise tolerances. Kramer had an engineering degree from Technical University of Munich. Before the war, he'd worked on automotive design. He understood metallurgy, physics, and materials science. And looking at these fragments, he felt his stomach drop. This was a shaped charge, a hollow charge round. The Germans called it Hollladung. The principle was well understood. Detonate high explosive behind a precisely shaped cone of metal, and it focuses the blast into a superheated jet of molten metal and gas. That jet, traveling at hypersonic speeds, could burn through armor regardless of the projectile's velocity. The Germans used shaped charges in their own weapons: Panzerfaust anti-tank rockets, Panzerschreck launchers, satchel charges for engineers. These were devastating against armor, capable of penetrating thicknesses that conventional kinetic rounds couldn't touch. But shaped charges required careful design, precise manufacturing, and stable explosives. And most importantly, they needed to detonate at the exact right distance from the target. Too close or too far, and the jet dispersed, losing effectiveness. What Kramer was holding was evidence that the Americans had successfully weaponized shaped charge technology in artillery shells. Shells that could be fired from field howitzers, shells that could penetrate the frontal armor of a Panther tank, and if they were using them in 105mm howitzers, that meant they'd solved every major technical challenge. The shells had to survive the massive acceleration of being fired from a gun. They had to remain stable in flight. They had to detonate at precisely the right moment. This wasn't improvisation. This was sophisticated engineering, mass-produced and issued to frontline artillery units. Kramer did the calculations in his head. A well-designed shaped charge could penetrate 3 to 5 times its diameter in steel armor. A 105mm shaped charge could theoretically penetrate 300 to 500mm of armor. The Panther's effective frontal armor was 140mm. These rounds wouldn't just penetrate, they would over-penetrate. They would punch through and keep going, setting off ammunition, killing crew, destroying everything inside. This changed everything. The Panther's advantage was its frontal armor. That's what made it superior to the Sherman. Shermans had to flank, had to maneuver, had to get side shots, but Panthers could engage frontally with impunity. Except now they couldn't, because the Americans had given their infantry support howitzers ammunition that turned them into tank killers. And howitzers were everywhere. Every infantry battalion had them. Every armoured battalion had them. There were hundreds of them supporting the American lines at Krinkelt-Rocherath alone. Kramer wrote a detailed report that evening. He described the shell fragments, explained the physics of shaped charge penetration, and included diagrams showing the entry holes on the destroyed Panthers. His conclusion was stark. American forces have deployed hollow charge artillery ammunition capable of penetrating Panther frontal armor. These shells can be fired from standard field howitzers. Recommend immediate tactical doctrine revision. Panthers can no longer assault prepared positions with artillery support without prohibitive losses. The armor superiority we have relied upon has been negated by American engineering. He sent the report up the chain through official channels. 2 days later, it came back with a notation from division headquarters. Analysis deemed overly pessimistic. Panthers remain superior to all American armor. Artillery losses attributed to side hits and poor crew performance. Continue offensive operations. The report had been dismissed, not because it was wrong, but because accepting it meant acknowledging that Germany's tactical advantages were evaporating. But Kramer knew what he'd seen. He'd commanded tanks for 3 years. He'd fought in Russia, in France, in Belgium. He could tell the difference between a side hit and a frontal penetration. He could read the evidence, and the evidence was clear. The Americans had developed a weapon that made the Panther's greatest strength, its frontal armor, irrelevant. They'd done it quietly, without fanfare, without propaganda. They'd just issued the shells to their artillery units and let them get to work. What haunted Kramer was the implication. If shaped charge shells were being used in 105mm howitzers, that was just the beginning. The Americans could scale this technology. Larger calibers, different delivery systems, tank guns, anti-tank guns. The entire German doctrine of thick frontal armor and angled plating was about to become obsolete. Germany had spent years developing the Panther specifically to counter the 34. Heavy frontal armor, powerful gun, good mobility, and now a field howitzer, a weapon designed to lob high-explosive shells at infantry, could kill it from the front. The tactical ramifications were staggering. German armor doctrine was built around frontal engagements. Use superior armor to survive the initial exchange, then use the superior gun to destroy the enemy. But if the armor didn't matter, if anything could penetrate it, then German tanks lost their primary advantage. They became targets in a shooting gallery. Expensive, hard-to-replace targets. Kramer thought about production numbers. Germany was producing perhaps 300 Panthers per month. That was at full capacity, with factories running around the clock, using forced labor, cannibalizing other programs for resources. The Americans were producing thousands of vehicles per month, Shermans, tank destroyers, artillery pieces, and now they'd armed their artillery with ammunition that could kill Germany's best tanks. The mathematics was brutal. Even if German tanks were superior one-on-one, which they weren't anymore, the numbers were overwhelming. On December 21st, Kramer's Kampfgruppe was pulled out of the line. They failed to take Krinkelt-Rocherath. The northern shoulder of the offensive had stalled. Elsenborn Ridge remained in American hands. Of the 18 Panthers Kramer had started with on December 17th, only 9 were operational. 5 had been destroyed by shaped charge artillery rounds. 2 had been knocked out by tank destroyers. 2 had broken down and couldn't be recovered. A 50% loss rate in 4 days, against inexperienced American infantry. As his remaining Panthers withdrew through the snow, Kramer looked back at the burning village. He could see American positions, infantry in foxholes, tank destroyers hull down behind rubble, and those howitzers, still firing, sending their deadly cargo toward German positions, low-velocity artillery pieces that had become tank killers. It was a perfect metaphor for this entire war. Germany had focused on building wonder weapons, super-heavy tanks, jet fighters, rockets, technological marvels. Americans had focused on production, good enough weapons in overwhelming quantities, and they'd quietly added capabilities that made good enough into devastating. Kramer never wrote another report about the shaped charge ammunition. There was no point. The evidence was clear, the conclusions were obvious. But the Nazi leadership didn't want evidence or conclusions. They wanted victory, they wanted belief, they wanted soldiers to keep attacking, to keep dying, in service of an ideology that refused to acknowledge reality. So Kramer kept quiet. He commanded his Panthers, he did his duty. And he waited for the inevitable end, knowing that every attack, every engagement, every battle was bringing it closer. What he couldn't know, sitting in that frozen Belgian field in December 1944, was just how right he was. The American M67 high-explosive anti-tank round, the shaped charge shell that had killed his Panthers, was being produced by the thousands. Every 105mm howitzer in Europe had access to them. The M4 Sherman assault guns, mounting 105mm howitzers in turrets, could carry them into direct fire roles. Tank battalions, infantry battalions, artillery batteries, all armed with ammunition that made German armor superiority meaningless. And it wasn't just 105mm. The same technology was being adapted for 75mm guns, for infantry anti-tank weapons, for bazookas and recoilless rifles. The shaped charge revolution had arrived, and it rendered thick armor obsolete. The arms race that Germany thought it was winning, building heavier tanks with more armor, was over, because thickness didn't matter anymore. What mattered was explosive chemistry and precise engineering. And in that arena, American industrial capacity was unmatched. The Battle for Krinkelt-Rocherath continued for 3 more days. The 12th SS Panzer Division threw everything it had at American positions. More Panthers, Panzer IVs, infantry, artillery. The Americans held. Their tank destroyers picked off German armor from concealed positions. Their infantry fought building to building, and their 105mm howitzers kept firing those shaped charge rounds, turning every engagement into a potential tank killer. By Christmas Day, the German offensive in that sector had completely stalled. The northern shoulder held. Elsenborn Ridge remained impregnable, and the shaped charge secret was out. Other German units were reporting similar experiences. Panthers knocked out by artillery fire, Tigers penetrated by Sherman assault guns. The invincible armor that German doctrine depended on was being defeated by American engineering and mass production. After the war, when production figures were declassified, the scale of the M67 program became clear. The Americans had developed the round in 1943, conducted extensive testing, and put it into production in early 1944. By December of 1944, tens of thousands were in theaters. Every 105mm howitzer could fire them. Every assault gun carried them. The round could penetrate 140mm of armor at any angle between 0 and 60 degrees. It made no difference if you shot at 100 meters or 1,000 meters. The shaped charge didn't care about velocity. It cared about chemistry. The M67 weighed about 33 pounds. It was 19 inches long. It contained a carefully shaped copper liner and high-grade explosive. When it hit a tank, it would detonate on contact, forming a jet of superheated copper and gas that travelled at over 8,000 meters per second. Nothing could withstand that. No armor Germany could produce. No angle of attack Germany could achieve. The physics were unforgiving. For German tank crews, this was devastating. The Panther was supposed to be their answer to Allied numerical superiority. Thick frontal armor meant they could engage multiple enemies and survive. Superior optics and guns meant they could kill at range. But shaped charges negated both advantages. Range didn't matter when penetration didn't depend on velocity. Armor thickness didn't matter when the jet could punch through anything. German tanks became targets, not threats. Kramer survived the war. He was captured by American forces in March 1945 as Germany collapsed. During interrogation, American technical intelligence officers were particularly interested in his reports about the shaped charge ammunition. They showed him photographs of destroyed Panthers, asked him to identify the type of damage, and explain what his crews had experienced. Kramer told them everything. There was no reason to hold back. The war was over. One American officer, a captain from Army Ordnance, was particularly interested in Kramer's December 1944 report. "You understood what you were facing." "Yes," Kramer said. "I studied engineering. I recognized shaped charge damage. It wasn't difficult to deduce." "But your superiors ignored the report?" "They dismissed it. Acknowledging it would mean acknowledging that our armor doctrine was obsolete, that we were facing an enemy with industrial capacity we couldn't match." The captain nodded. "The M67 round was one of our most closely guarded secrets. We developed it specifically to give our howitzers an anti-tank capability. Your Panthers were the primary target." "It worked," Kramer said quietly. "My men died because your engineers were better than ours. Not braver, not more determined, just better at industrial chemistry and mass production." The American looked uncomfortable. "For what it's worth, we respected the Panther. It was a formidable machine." Kramer smiled bitterly. A formidable machine that could be killed by a field howitzer firing a 33-pound shell. That's the lesson of this war, isn't it? Technology matters, but production matters more. You didn't need the best tank. You just needed enough good tanks, with enough good ammunition, operated by enough good crews, and you had all of that. The interrogation report noted that Kramer was unusually candid for a German officer. He showed no interest in defending Nazi ideology or German military doctrine. When asked why, he said simply, "I saw the evidence. I wrote the reports. I understood what was happening. Lying about it now serves no purpose." The American officers forwarded his technical observations to Aberdeen Proving Ground, where they contributed to post-war analysis of shaped charge effectiveness. Years later, military historians would study the Battle of Krinkelt-Rocherath as a case study in how technology can shift tactical balance. The German attack, which should have succeeded based on traditional metrics of force ratio and combat power, failed partly because the Americans had quietly introduced a capability that German doctrine couldn't counter. Shaped charge artillery ammunition made fortified positions more deadly, reduced the effectiveness of heavy armor, and forced German commanders to choose between unacceptable casualties and mission failure. The story of Fritz Kramer and the M67 heat round is a microcosm of Germany's defeat. Time and again, German officers identified problems, wrote accurate reports, and provided sound analysis. And time and again, those reports were dismissed because they contradicted Nazi ideology. The belief that German engineering was superior, that German will could overcome material disadvantage, that technology and tactics could defeat industrial capacity, all lies, comfortable lies that allowed the leadership to ignore reality until reality became inescapable. Kramer had seen the evidence in December 1944, shaped charge shells punching through Panther armor, American howitzers functioning as tank killers. A technological advancement that negated Germany's tactical advantages. He'd documented it, explained it. I was warned about it, and been ignored, because acknowledging the truth meant acknowledging that the war was already lost, not in December 1944. But years earlier, when Germany chose ideology over evidence, belief over mathematics, myth over material reality, the Panthers kept dying, the reports kept being dismissed, and the war ground toward its inevitable conclusion. The shaped charge rounds at Krinkelt-Rocherath were just one small example of a larger truth. In industrial warfare, production capacity matters more than individual weapon quality. The Americans understood this. They built weapons that were good enough, in quantities that were overwhelming, supported by industrial infrastructure that dwarfed anything Germany could match. And when they identified a capability gap, like the need to give howitzers anti-tank capability, they solved it through engineering and mass production. Germany, meanwhile, kept building wonder weapons, heavy tanks that broke down, jets that lacked fuel, rockets that couldn't change the strategic situation. Technological marvels produced in handfuls, too few and too late to matter, while American factories were producing thousands of shaped charge rounds per day, giving every artillery battery the ability to kill German armor. That was the real gap. Not technology, not tactics, not soldier quality. Industrial capacity and the willingness to apply it systematically to every problem. As Fritz Kramer sat in an American POW camp in 1945, he thought about those shell fragments he'd examined in Belgium. The precisely machined copper liner, the carefully calibrated explosive, the engineering sophistication required to make a shaped charge function reliably when fired from a howitzer. American engineers had solved problems German engineers were still struggling with, not because they were smarter, but because they had better facilities, more resources, and an industrial system that could turn ideas into reality at scale. That was the lesson Kramer took from the war. Technology matters, tactics matter, training matters, but in the end, industrial capacity matters most. The side that can produce more, replace faster, and sustain longer will win. Germany had gambled that early victories and superior weapons would force a quick decision. They'd been wrong. America had built an industrial war machine that turned out tanks, planes, ships, and ammunition faster than Germany could destroy them. And they'd quietly armed those weapons with capabilities like shaped charge ammunition that made German advantages irrelevant. The M67 heat round didn't win the war. No single weapon did. But it was representative of how the war was won. Identify a need, engineer a solution, mass produce it, deploy it, iterate based on battlefield feedback. The American military-industrial complex operated like a factory assembly line, taking problems as inputs and generating solutions as outputs. Germany, hamstrung by Nazi ideology, resource constraints, and strategic overreach, couldn't match that pace. So Panthers died in Belgian villages, killed by howitzers that weren't supposed to threaten them. Tiger tanks were knocked out by tank destroyers, armed with shaped charge rounds. German armor, the pride of the Wehrmacht, became vulnerable to weapons they'd been designed to resist. And officers like Fritz Kramer wrote reports that were filed away, marked no action required, while the industrial tide continued to rise, inexorable and overwhelming, until it swept away everything in its path. That was December 1944 in a frozen Belgian village. That was Krinkelt-Rocherath. That was the moment when a German tank commander realized his nation had lost a war that leadership refused to acknowledge. Not lost because of cowardice, not lost because of poor tactics, lost because the other side had better factories, better logistics, and better engineering. And in industrial warfare, that was all that mattered. The development of the M67 heat round had begun in quiet laboratories and proving grounds far from the battlefield. While German engineers were focused on building bigger guns and thicker armor, American engineers were solving a different problem: how to give every artillery piece the ability to kill tanks. The concept of shaped charges wasn't new. Physics had been understood since the 1800s. Swiss scientist Charles Munro had documented the effect in 1888. He found that explosives with cavities focused their blast in predictable ways. German scientists had expanded on this work before World War II, developing the theory behind hollow charge warheads. But theory and practice are vastly different. Creating a shaped charge that works in a laboratory is one thing. Creating one that can survive being fired from a gun is entirely different. When an artillery shell is fired, it experiences forces of 15,000 to 20,000 times gravity. That acceleration would destroy most precision mechanisms. The explosive has to remain stable. The liner has to stay precisely aligned. The fusing has to function reliably. And all of this has to happen in a package that could be mass-produced and shipped around the world. American engineers at Aberdeen Proving Ground and private contractors worked on this problem throughout 1942 and 1943. They tested different liner materials. Copper proved optimal, providing the right combination of malleability and density. They experimented with explosive compositions. Composition B, a mixture of RDX and TNT, provided consistent performance. They designed fuses that would detonate on contact but wouldn't be triggered by the acceleration of firing. Each component required extensive testing, thousands of test firings, analysis of failures. Incremental improvements. By early 1944, they had a working design. The M67 round consisted of a thin-walled steel shell body containing a precisely shaped copper liner backed by 9 pounds of Composition B explosive. The nose contained a base-detonating fuse that would trigger on impact. The entire assembly was designed to function at any angle between 0 and 60 degrees from perpendicular. This meant it would work whether fired directly at a target or lobbed in a high arc. Range didn't matter. Velocity didn't matter. Only the shaped charge physics mattered. The production orders went out in February 1944. Multiple contractors received specifications. Die forges shaped the copper liners. Munitions plants loaded the explosives. Assembly lines put the components together. Quality control inspectors checked each round. By June 1944, when Allied forces landed in Normandy, thousands of M67 rounds were available in ammunition dumps across England. By December, tens of thousands were in Europe. German intelligence knew something was happening. They'd captured American ammunition stocks. They'd found shaped charge rounds. But the full scope of the program remained hidden. German analysts assumed these were specialized rounds, available in limited quantities, used only in specific situations. They didn't understand that the Americans had industrialized shaped charge production, that every 105mm howitzer in Europe could access heat ammunition, that field artillery batteries were being trained in direct fire anti-tank tactics. The scale and systematization was invisible until it manifested on battlefields like Krinkelt-Rocherath. This pattern, systematization and scale, was characteristic of American war production. When the US identified a need, the response wasn't to build a few excellent solutions. It was to build thousands of good solutions. The M67 wasn't the best possible shaped charge round. German engineers could have designed something more sophisticated, but the M67 was good enough, reliable enough, and manufacturable enough to be produced in massive quantities. That was the American advantage. Not peak performance, consistent, overwhelming production. Other German tank commanders were having similar experiences to Fritz Kramer. In the forests around Bastogne, Panzer Lehr Division encountered American 105mm assault guns firing heat rounds at point-blank range. Near Street, Vith, tank destroyers armed with 76mm heat ammunition knocked out Panthers from positions they'd considered safe. The shaped charge revolution was happening across the entire Ardennes battlefield. German armor, which should have been decisive, was being neutralized by American firepower. Oberst Otto Rimmer commanded the Führer Begleit Brigade during the Bulge. His unit included the newest Panther AUSF-Gs, upgraded with improved armor and optics. On December 20th, his lead company advanced toward an American roadblock near Vielsalm. The intelligence report said minimal resistance, light infantry, a few tank destroyers. Standard doctrine was to lead with Panthers, suppress American positions with fire, then push through with infantry to clear any remaining resistance. The Panthers moved forward in a column. The road was narrow, flanked by forest. Perfect ambush terrain, but intelligence said the Americans had pulled back. The first indication of trouble was when the lead Panther exploded. Not a glancing hit, not a mobility kill. A complete catastrophic explosion that scattered debris across 50 meters. Remmer's executive officer radioed immediately. What hit him? Unknown, Herr Oberst. Looked like artillery, high-angle trajectory. But artillery didn't cause catastrophic kills on Panthers. Not from the front, not with one shot. The second and third Panthers in the column stopped, crews frantically searching for targets. Then another explosion. The second Panther's turret lifted straight up, propelled by ammunition detonating inside the hull. Now Reimer could see the source. American positions ahead and to the flanks. Not tank destroyers, not anti-tank guns, Sherman tanks, but not regular Shermans. These had shorter, fatter barrels, 105mm Howitzers. Assault guns. The Americans were using infantry support vehicles as tank destroyers. The third Panther tried to reverse. Too late. Another shell impacted the glacis plate. Clean penetration. The crew bailed out through the top hatches as smoke poured from the driver's compartment. 3 Panthers dead in 90 seconds. Reimer ordered the column to pull back. His Tigers could engage from longer range, suppress the American positions. But the psychological damage was done. His men had watched their best tanks destroyed by weapons that weren't supposed to threaten them. That evening, Reimer examined the disabled Panthers. All 3 showed the characteristic signs of shaped charge penetration. Small entry holes, melted metal around the edges, catastrophic internal damage. One of his technical officers, a former industrial chemist, examined the shell fragments they'd recovered. His analysis matched Kramer's. American-shaped charge ammunition, manufactured to precise tolerances, available in quantities that suggested mass production. Reimer included this information in his daily report. The response from Army headquarters was terse. Maintain offensive momentum. German armor remains superior to all Allied vehicles. But Reimer's men had seen otherwise. They'd watched Panthers explode. They'd recovered crew members who'd been inside when shaped charge jets penetrated. The internal damage was horrific. The superheated metal and gas jet would cut through ammunition racks, fuel tanks, hydraulics. Everything inside the tank became shrapnel. Even crew members who weren't directly hit would be injured by the overpressure wave. Surviving a shaped charge penetration required immediate evacuation and extraordinary luck. The mathematics told the story. A Panther cost approximately 117,000 Reichsmarks to produce. It required specialized steel alloys, precision manufacturing, skilled labor. Production capacity was limited. Germany could build perhaps 20 to 30 Panthers per day across all factories. Each loss was significant. Each crew killed represented months of training that couldn't be replaced. The attrition rate was unsustainable. An M67 heat round cost approximately $60 to produce. Copper liner, explosive, steel casing, fuse, standard industrial components. American factories could produce thousands per day. The ammunition was interchangeable. Any 105mm howitzer could fire it. Any trained crew could load it. The rounds were shipped to Europe by the ton, stored in ammunition dumps, and distributed to artillery batteries. When crews expended them, more arrived. The logistics were seamless, industrial, and overwhelming. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. This disparity, expensive, irreplaceable tanks versus cheap, plentiful ammunition, characterized the entire Ardennes offensive. Germany threw its strategic reserve into the battle. Panthers, Tigers, Panzer IVs, the best equipment that remained. Against this, the Americans deployed mass, thousands of tanks, thousands of tank destroyers, thousands of artillery pieces, and crucially, ammunition in quantities that seemed inexhaustible. German units would report destroying American vehicles, only to find them replaced the next day. American units would expend ammunition freely, knowing supply convoys would bring more. The shaped charge issue extended beyond just 105mm howitzers. American tank destroyers used 76mm heat rounds. Infantry carried bazookas, essentially handheld shaped charge launchers. Combat engineers had satchel charges. At every level, from individual soldiers to battalion-level artillery, the Americans had shaped charge capabilities. This meant German armor faced threats from every angle, at every range, in every tactical situation. The armor that was supposed to provide protection had become vulnerable. Tanks were bullet magnets, drawing fire from every American weapon system. German tankers developed unofficial tactics to try to mitigate the threat. Keep moving to avoid providing a stable target. Stay buttoned up to protect against artillery shrapnel. Avoid urban terrain where shaped charge weapons could ambush from close range. Use infantry screens to suppress American positions before tanks advanced, but these tactics couldn't solve the fundamental problem. The shaped charge didn't care about movement, it didn't care about range, it just needed to hit the tank, and with American artillery firing hundreds of rounds per engagement, hits were inevitable. Lieutenant Hans von Luck commanded a reconnaissance battalion in the Ardennes. His unit included several captured American vehicles, which they used for infiltration and reconnaissance. On December 23rd, his men captured an American supply dump near Hotten. Among the crates of rations and fuel, they found ammunition, hundreds of 105mm shells. Von Luck's ordnance officer examined them. Approximately 30% were marked M67, heat ammunition. The presence of so many shaped charge rounds in a random supply dump indicated massive availability. The Americans weren't rationing this ammunition, they were using it as a standard issue. Von Luck reported this finding. His analysis was pragmatic. If 1/3 of American artillery ammunition is anti-tank capable, then every artillery concentration threatens our armor. We cannot mass tanks for assault without risking catastrophic losses. Recommend shifting to infiltration tactics using infantry and light vehicles. The response from division was predictable. Continue offensive operations. Armor will lead all assaults. German fighting spirit will overcome material disadvantages. But fighting spirit couldn't stop shaped charge jets. Physics didn't care about ideology. The mathematics were unforgiving. A copper liner, precisely shaped, backed by high explosive, would form a jet capable of penetrating any armor Germany fielded. No amount of determination changed that. No amount of tactical skill made Panthers immune. The only solution was to not get hit. And in an environment where American artillery fired thousands of rounds per day, not getting hit was impossible. The Battle of the Bulge ended in January 1945 with German forces in full retreat. The offensive had failed catastrophically. Thousands of tanks were lost. Tens of thousands of casualties, strategic reserves exhausted. The fuel crisis that everyone had warned about proved decisive, but the shaped charge issue had been equally important. German armor, which was supposed to punch through American lines and drive to the Moose River, had been stopped by defenses anchored on artillery positions firing heat ammunition. The invincible Panthers and Tigers had proven vulnerable. The armor advantage that German doctrine depended on had evaporated. After the battle, American technical intelligence teams swept the battlefield, documenting destroyed German vehicles. They found Panthers with frontal penetrations, Tigers knocked out by shaped charges, Panzer IVs destroyed by heat rounds from bazookas. The weapons had performed exactly as designed. The shaped charge revolution had arrived, and it had fundamentally changed armored warfare. Thick armor wasn't protection anymore, it was just an expensive weight. German engineers examined captured M67 rounds with professional interest. The design was elegant, simple materials, precisely assembled. The copper liner was stamped, not machined, making production faster. The explosive was standard composition B, widely available. The fuse was reliable and cost-effective. Everything about the round reflected industrial thinking. Not the best possible design, but a very good design that could be mass-produced. That was the American way of war. Good enough, repeated 10,000 times, beat excellently once. Could Germany have produced equivalent rounds? Yes. German engineers understood shaped charge physics. They had theoretical knowledge. They could have designed competitive ammunition, but they lacked industrial capacity. Copper was scarce. Explosives production was stretched thin. Manufacturing facilities were being bombed. Labor was increasingly forced and unskilled. Quality control was declining. And even if Germany could have produced shaped charge ammunition, they couldn't have matched the American scale. Thousands of rounds per day required an industrial infrastructure Germany didn't possess. This pattern, theoretical capability, without practical capacity, characterized Germany's late-war position. German engineers could design sophisticated weapons, jets, rockets, advanced tank destroyers. But designing a weapon and producing it in decisive quantities are different challenges. The Americans understood this. They were designed for production, simplified manufacturing, standardized components, distributed production across multiple contractors, built redundancy into the supply chain. When one factory was damaged, others continued. When one component proved difficult to manufacture, they redesigned it. The German approach was different. Build the best possible weapon. Optimize for performance. Accept manufacturing complexity. Concentrate production in specialized facilities. Rely on skilled craftsmen for critical components. This approach worked when Germany had industrial dominance. It failed when resources became constrained and facilities were targeted by strategic bombing. The wonder weapons that German propaganda celebrated, Panthers, Tigers, jets, rockets, were manufactured in handfuls while American good-enough weapons flooded the battlefield in thousands. Fritz Kramer, sitting in that POW camp, understood this completely. He'd seen it at Krinkelt-Rocherath, American howitzers, unremarkable field artillery pieces, armed with shaped charge ammunition that negated German armor advantages. Simple, effective, mass-produced. While Germany had focused on building the ultimate tank, the Americans had focused on arming every artillery battery with tank-killing capabilities. Both approaches were engineering solutions, but only one was industrially scalable. The M67 heat round remained in American service through the Korean War. Later versions were developed with improved penetration and reliability. The basic principle, shaped charge in an artillery shell, became standard worldwide. Modern artillery still fires heat ammunition. The innovation that killed Panthers in Belgian forests in 1944 evolved into a permanent feature of armored warfare. Thick armor alone could never again provide absolute protection. The shaped charge had changed the rules permanently. For German tankers who survived, the lesson was bitter. They'd believed in their equipment. Panthers were superior to Shermans in almost every measurable way. Better gun, better armor, better optics. But superiority in traditional metrics didn't matter when the enemy changed the game. By weaponizing shaped charge technology in artillery, the Americans had made traditional armor warfare obsolete. The Panther's advantages, frontal armor and powerful gun, became irrelevant when a howitzer shell could kill it from any angle at any range. This represented a fundamental shift in military technology. For decades, the arms race had been about bigger guns versus thicker armor. Each generation of tank had more armor than the last. Each generation of anti-tank gun had more penetration. The cycle drove tank design toward heavier vehicles with increasingly thick plating. The Tiger II, with its 180mm of frontal armor, was the logical endpoint of this progression. But shaped charges broke the cycle. Penetration no longer required kinetic energy, it required chemistry. And chemistry didn't care how thick the armor was. German military theorists had predicted shaped charges would revolutionize warfare. They just thought Germany would be the one revolutionizing. German infantry used Panzerfaust and Panzerschreck effectively throughout the war. German engineers understood the technology intimately, but they never weaponized it at scale in artillery. They never gave their howitzers heat ammunition. They never systematized shaped charge production the way America did. This wasn't because of lack of knowledge, it was because of lack of industrial capacity and strategic focus. America approached the problem differently. Identify a capability gap, field howitzers can't kill tanks, define requirements, create ammunition that enables tank kills without requiring new weapons, engineer a solution, shaped charge round compatible with existing guns, industrialize production, manufacture at scale, deploy systematically, equip all artillery batteries. The process was methodical, industrial, and devastatingly effective. By the time German forces encountered heat ammunition in meaningful quantities, it was too late to adapt. The Ardennes offensive broke the back of German armour in the west. By February 1945, fewer than 200 German tanks remained operational on the entire Western Front. American and British forces had thousands. The qualitative edge that German tanks had once possessed was gone. Even the quantitative situation was hopeless, and lurking in every American artillery position were howitzers loaded with shaped charge ammunition, ready to kill any German tank foolish enough to come into range. Fritz Kramer returned to Germany after his release from POW camp. He never wrote about his wartime experiences. When asked about the Panther, he would only say, "It was a good tank." But good wasn't good enough. The war hadn't been lost on battlefields. It had been lost in factories, in laboratories, in the systematic application of industrial capacity to military problems. Germany had hoped that superior tactics and superior weapons would overcome American numerical advantage. They'd been wrong. America's advantage wasn't just numerical, it was systematic, industrial, and inexorable. The shaped charge rounds at Krinkelt-Rocherath were emblematic of this. A relatively simple weapon, engineered competently, manufactured at scale, deployed systematically. Not a wonder weapon, not a technological breakthrough, just good engineering, mass-produced, and properly employed. That was how America won the war. Not through brilliant individual weapons, but through the systematic application of adequate solutions at an overwhelming scale. Panthers were excellent tanks, but excellence doesn't matter when you're outnumbered 10-1, and the enemy's adequate weapons can kill you just as dead. Years after the war, American engineers would reference the M67 program as a model of effective military development. Identify a need, engineer a practical solution, test thoroughly, produce at scale, deploy widely, support with training and logistics, iterate based on feedback. This systematic approach, boring and methodical, proved more effective than trying to build wonder weapons. It was the difference between winning and losing, between having shaped charge ammunition available in every artillery battery versus having advanced designs sitting in laboratories while the war was lost. German generals blamed many factors for defeat. Hitler's interference, strategic overreach, the two-front war, resource shortages, Allied bombing. All these were real factors, but they missed a fundamental truth. Germany was fighting an industrial war with an inadequate industrial base. Every advanced weapon they designed, every technological breakthrough they achieved, had to be weighed against production capacity. Could they build enough to matter? Could they deploy it widely enough to change outcomes? Usually, the answer was no. Meanwhile, American factories churned out good enough weapons in quantities that swamped any German qualitative advantage. The M67 heat round killed Panthers in Belgium. It killed Tigers in France. It killed Panzer IVs and Jagdpanthers and Stugs across Western Europe. Not because it was a miracle weapon, because it was available, reliable, effective, mass-produced. The epitome of American military-industrial philosophy. Give good tools to many soldiers beats giving excellent tools to few soldiers. Simple, obvious, devastating. Fritz Kramer died in 1983. In his effects, his family found the report he'd written in December 1944, the one that had been dismissed, the analysis of shaped charge ammunition, the warnings about American industrial capacity, the calculations showing why German armor doctrine was obsolete. Next to it was a note, written decades later, "I was right." But being right didn't matter. They weren't listening. They never were. That note, more than any combat report or intelligence assessment, captured the tragedy of Germany's defeat. Competent men saw the truth, reported it accurately, and were ignored because truth conflicted with ideology. Reality was subordinated to belief until reality became inescapable. The shaped charge revolution continued after World War II. Modern anti-tank weapons rely almost exclusively on shaped charge warheads. Tank armor evolved to counter them, with reactive armor and composite materials. The arms race continued, But the fundamental lesson remained. Industrial capacity matters more than individual weapon performance. The side that can produce more, adapt faster, and sustain longer wins. Technology matters, tactics matter, but industry matters most. But the story of the M67 and its impact on German armour didn't end at Krinkelt-Rocherath. Across the entire Ardennes front, similar scenarios played out with devastating consistency. Near Bastogne, the 101st Airborne Division, surrounded and outnumbered, held off repeated German armour attacks, partly because their supporting artillery battalions had adequate supplies of heat ammunition. When German tanks approached American perimeters, howitzers would switch from indirect fire support to direct fire anti-tank mode. The psychological impact on German tank crews was profound. They were being killed by weapons they'd been trained to ignore. Hauptmann Werner Sternebeck commanded a Panther company in the 2nd Panzer Division. His unit was tasked with cutting the road to Bastogne near Neuville on December 19th. Intelligence briefings had emphasized American weakness. Airborne troops, lightly equipped, low on ammunition, demoralized by encirclement, his Panthers should have crushed them. Instead, Sternebeck watched 4 of his tanks destroyed in the first hour of fighting, not by tank destroyers, not by concealed anti-tank guns, by artillery fire that seemed impossibly accurate and impossibly lethal. After the engagement, Sternebeck examined the wrecks. Every penetration showed the same characteristics: small entry hole, extensive internal damage, evidence of extreme heat. He'd seen enough combat to recognize shaped charge effects. But the scale disturbed him. This wasn't a handful of specialized rounds carefully rationed. This was systematic employment of anti-tank artillery ammunition. When he interrogated a captured American artilleryman, the soldier confirmed it casually. "Yeah, we got heat rounds. Use them when tanks show up. Works pretty good." The nonchalance was chilling. To the Americans, this was routine, standard procedure, nothing special. Sternebeck's after-action report noted something that Fritz Kramer had also observed. The Americans weren't just using shaped charge ammunition defensively, they were incorporating it into offensive operations. Sherman assault guns, mounting 105mm Howitzers, were being used in the assault role, leading tank formations with the explicit mission of engaging German armour. This inverted traditional doctrine. Howitzers supported attacks, they didn't lead them. But armed with heat ammunition, these assault guns became hybrid vehicles. Artillery that could kill tanks, tanks that could provide artillery support. The flexibility was tactically devastating. German tank destroyer units faced a similar crisis of confidence. The Jagdpanther, armed with the 88mm Pak 43, was designed to kill Allied tanks at extreme range. Its thick frontal armour and powerful gun made it nearly invincible in the defensive role. But at Krinkelt-Rocherath and elsewhere, Jagdpanthers were being knocked out by American howitzer fire. Their armour, while thick, wasn't immune to shaped charges, and their lack of turret meant they couldn't respond quickly to threats from multiple directions. When American artillery could kill them frontally, the Jagdpanthers' advantages disappeared. The production economics were stark. A Jagdpanther cost approximately 160,000 Reichsmarks to build. It required the hull of a Panther, extensive modifications, specialized armor plating, and the complex 88mm gun. Germany produced roughly 400 Jagdpanthers during the entire war. Each loss was strategically significant. An M67 heat round cost $60. The United States produced over 40,000 during the war. A single Jagdpanther represented an investment equivalent to roughly 45,000 heat rounds, and one heat round could kill the Jagdpanther. The mathematics were absurd. This asymmetry extended to crew training. A German Panther crew required months of training. Driver training alone took weeks, learning to manage the complex transmission and steering systems. Gunner training required extensive practice with the optics and range-finding equipment. Commander training involved tactical decision-making, radio procedures, coordination with infantry. Replacing a killed crew meant pulling soldiers from other units, or training new recruits from scratch. Time Germany didn't have. An American artillery crew could be trained to fire HET ammunition in hours. The rounds loaded the same way as high-explosive shells. The fusing was automatic. The only difference was selecting the ammunition type and adjusting fire for direct shots instead of indirect fire. Any competent artillery crew could employ heat rounds effectively with minimal additional training. This meant the capability could be distributed widely and rapidly. No specialized units required. No lengthy training pipeline, just issue the ammunition and brief the crews. The logistical dimension was equally important. German armor required specialized supply chains. Panthers needed specific spare parts, manufactured in dedicated facilities. Fuel consumption was high, and German logistics struggled to keep frontline units supplied. Ammunition for the 75mm KK-42 gun was produced in relatively limited quantities. German tank units operated on thin margins. When something broke, repairs took time. When ammunition ran low, resupply was uncertain. American howitzer ammunition was part of a massive, redundant logistics network. Multiple ports received shipments from the United States. Multiple ammunition dumps stored shells. Multiple transportation routes moved supplies forward. If one facility was bombed, others continued. If one convoy was intercepted, others got through. The system was designed with redundancy at every level. Heat rounds were just one more ammunition type in the pipeline. They shipped alongside high-explosive rounds, smoke rounds, illumination rounds. The logistics treated them as routine, which meant they were always available. This logistical superiority manifested in battlefield behavior. American artillery units fired thousands of rounds per day. They didn't carefully husband ammunition. They didn't ration shots. When they saw a target, they fired. If the first round missed, they fired again, and again, until the target was destroyed. This volume of fire was only possible because the logistics network could sustain it. German artillery, by contrast, operated under constant ammunition constraints. Every shot had to count. Every mission had to be justified. The disparity in available firepower was enormous. German commanders tried various tactical adaptations. Some ordered tanks to operate in more dispersed formations, reducing the effectiveness of artillery concentrations. But dispersion made coordination difficult and reduced mutual support. Some ordered tanks to move constantly, never presenting a stationary target, but constant movement increased fuel consumption and mechanical wear. Some ordered tanks to attack only at night, when American artillery observation was degraded. But night attacks were difficult to coordinate and often dissolved into chaos. None of these adaptations addressed the fundamental problem. American artillery with heat ammunition could kill German tanks, period. No amount of tactical creativity changed that basic fact. The only real counter would have been to suppress American artillery before it could fire. But German counter-battery capability was limited. American artillery was supported by aerial observation, sound ranging, and flash spotting. German guns were quickly located and destroyed. The artillery duel was as one-sided as the tank engagements. Some German officers proposed bypassing American strongpoints entirely. If artillery-supported positions were too costly to assault, go around them. Focus on infiltration and exploitation rather than frontal attacks. This was tactically sound, but it required freedom of maneuver that the Ardennes terrain didn't allow. Roads were limited. Alternatives were poor. American positions controlled key terrain. Bypassing them meant abandoning the offensive's timetable. And the timetable was everything. The offensive had to achieve breakthrough and exploitation within days before American reinforcements arrived. Delay meant failure, so the attacks continued. Panthers and Tigers and Panzer IVs threw themselves against American positions, anchored on artillery that could kill them. The casualty rates were horrific. German armor losses in the Ardennes exceeded 40%. Not all from heat ammunition, certainly, but enough that every German tank commander knew the threat was real, knew that their armor wasn't protection anymore, knew that American howitzers were as dangerous as anti-tank guns. The The psychological weight of that knowledge was crushing. Some crews simply refused to advance. Not openly, not in defiance of orders, but mysteriously. Tanks would develop mechanical problems. Engines would fail to start. Transmissions would malfunction. Tracks would throw. Crews knew that advancing meant potential death from weapons they couldn't effectively counter. Staying back, claiming mechanical failure, offered survival. German officers recognized this pattern but couldn't stop it. Shooting crews for cowardice would have destroyed unit cohesion completely. So they accepted the unofficial work stoppage and tried to make do with whoever was willing to advance. The American advantage in shaped charge technology extended beyond just artillery. Infantry bazookas used shaped charge warheads. By December 1944, the complete M9 bazooka was standard issue, replacing the earlier M1 model. The M9 could penetrate approximately 120 millimeters of armor, not quite enough to reliably penetrate a Panther's glacis, but more than sufficient for side or rear shots. And bazookas were everywhere. Every infantry company had them. Every defensive position included bazooka teams. German tanks that penetrated American lines found themselves under fire from multiple directions, from weapons that could kill them at close range. The cumulative effect was paralysis. German armor, which was supposed to be the spearhead of the offensive, became reluctant to advance. If this deep dive into World War II technology is blowing your mind, take a second to hit that like button and share this story with anyone who loves military history. Officers who pushed their units forward faced devastating losses. Officers who held back failed to achieve objectives. There was no good option. The shaped charge revolution had fundamentally altered the tactical calculus. Armor was no longer dominant. It was vulnerable, and vulnerability meant hesitation. Hesitation meant delay. Delay meant failure. By early January 1945, as the Ardennes offensive collapsed, German armor strength in the West had been shattered. Units that had entered the battle with 50 or 60 tanks emerged with 15 or 20. Some were destroyed in combat. Some broke down and couldn't be recovered. Some were abandoned for lack of fuel, but a significant percentage were killed by American artillery firing hate ammunition. The weapon that wasn't supposed to threaten tanks had become one of the primary tank killers of the battle. That was the lesson of Krinkelt-Rocherath. American howitzers firing shaped charge ammunition killed German Panthers because America had the industrial capacity to develop, produce, and deploy that ammunition at scale. Not because American engineers were smarter, not because American soldiers were braver. Because American factories were more productive, American logistics more efficient, American industry more capable. The M67 heat round was just one small piece of that larger picture, but it was representative. Simple solution, mass-produced, devastating effect. And it helped end the myth of German armor invincibility in the frozen forests of Belgium, one shaped charge jet at a time. Thank you for reading. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.